Just like equations, we have some basic moves to let us solve inequalities. We can add the same number on both sides, and we can multiply by the same number on both sides. And with equations, there were no complications here. With inequalities, because the order matters, there are two times when we need to reverse the direction of the inequality sign. If we multiply or divide by a negative number, and if we switch the order of the inequality. So we want to switch which side each symbol is on. We need to switch the direction of the inequality. So let's just do some examples of solving some inequalities. Here we have 2x minus 3 is greater than or equal to 7. The first thing we want to do is get rid of subtracting 3, so we'll add 3 to both sides. On the left, we're just left with 2x. On the right, 7 plus 3 is 10. Then we want to get rid of the 2, so we'll divide both sides by 2. So on the left, then, we just have x. Then 10 divided by 2 is 5. The solutions to this inequality are any numbers that are greater than or equal to 5. So in set builder notation, we can say the set of all x such that x is greater than or equal to 5. Now, we see sets like this a lot, so we actually have another notation for describing just the kind of sets that we get as solutions to inequalities. We'll see that other notation a little bit later. For now, we're going to describe these solution sets in set builder notation. Next example. We'd like to solve 12 is less than 5x minus 3. So just because our variable is on the right doesn't mean we can't solve this. We just follow the same steps. First, we'll add 3 to both sides, right? Because we're trying to get x by itself. So on the left, we have 12 plus 3 is 15. On the right, we're just left with the 5x. So we have 5x. We want to get rid of that 5. So we need to divide both sides by 5. On the left, we'll have 15 divided by 5 is 3. And then on the right, we're just left with x. And we could just leave that way. But typically, when we've solved something, we want to write the variable on the left. So the last thing we're going to do here is switch the order. So we'll write x first and 3 second, but x is still the greater number. So 3 is less than x. That means the same thing as x is greater than 3. In set builder notation, the solution set is the set of all x such that x is greater than 3. Okay, let's see one more. This is something that we see with inequalities that we don't really see with equations. In this inequality, we're saying 7 is less than or equal to 1 minus 3x, which is less than 13. So this is actually two inequalities strung together. Right, we have our first inequality here, and then we have our second inequality here. There are two comparisons being made to 1 minus 3x. Now this is something we don't really see with equations, because it's hard to be equal to two different numbers at the same time, right? But with inequalities, it's easy to be greater than one number and less than another. We use one of these strung together inequalities when we want to describe our unknown being between two numbers. Notice when we write this, if we look at the ends here, the number 7 is less than the number 13. So the same inequality that we've written to string this together can be written between the numbers on the ends. That's the only time we'll use this between two things notation, is when the numbers are in order, either from least to greatest or from greatest to least. If you have one of these between type inequalities and it's not the case that the same inequality relates the ends, something has gone terribly wrong. Okay, so we can solve this all in one go, just keeping in mind that we're solving two inequalities at the same time. What does that look like? Because this is a situation that might be a little bit less familiar, I'm actually going to write something to indicate what I'm doing at each step. I want to get rid of this 1, so I want to subtract 1 in the middle. Now, focusing on the left inequality, I want to subtract 1 on the left, and focusing on the right inequality, I want to subtract 1 on the right. So on the left, 7 minus 1 is 6. I'm subtracting, so I can just copy my inequality symbol. I don't need to worry about the direction. In the middle, when I subtract 1, I'm just left with the negative 3x. On the right, 13 minus 1 is 12. So what we've just done is to subtract 1 from all sides. Right? So that means we're subtracting 1 on both sides in each inequality. Next, we need to get rid of that negative 3 in the middle. So we're going to divide by negative 3. Focusing on the left inequality, we'll divide by negative 3 on the left. Focusing on the right inequality, we'll divide by negative 3 on the right. And so on the left, we have negative 2. In the middle, we're just left with x. On the right, we have negative 4. And we've just divided by a negative number. So that also reverses the directions of the inequalities. So we've got negative 2 is greater than or equal to x is greater than negative 4. What did we just do? We just divided by negative 3 on all sides. And note, before we divided and reversed the inequalities, 6 and 12, the ends had the appropriate relationship. After we divided and reversed the inequalities, the ends still have the appropriate relationship. So that's it. Negative 2 is greater than or equal to x is greater than negative 4. Now, when we write one of these between inequalities, it seems like less than is the natural symbol to use, right? We like to write these from least to greatest just because that's the way we're used to seeing numbers, going from least to greatest. So the last thing we can do is reverse the order. This is optional, but it's something we'll often see done. So the negative 4 comes first, and then x is greater than negative 4, so negative 4 is less than x. And then 2 is greater than or equal to x, so x is less than or equal to negative 2. Notice that when we do that, this is the relationship between x and negative 2. It's still the relationship between x and negative 2. This is the relationship between x and negative 4. It's still the relationship between x and negative 4. So the location of those symbols isn't what's important. What's important is which two expressions they're relating. Again, we can give this solution set in set builder notation. This is the set of all x such that negative 4 is less than x is less than or equal to negative 2. Although, if I were reading this out loud, I would probably say x is between negative 4 and negative 2. And then I would need to do some more talking to say that x is allowed to equal negative 2, but not negative 4. which is why we have this more precise mathematical notation. But if I were just describing this a little bit less formally, I would talk about x being between these two numbers. We can think of this kind of inequality as describing betweenness in some sense.